It's a All right, so I think most of you guys were here just now. If you have corrections to quizzes or something, turn them in the same place you turned them in on Canvas in the first place. If you have really old homework or really old corrections, I can't remember, I think I put some specific things on Canvas for you to turn in corrections from earlier, but just try to minimize the amount of stuff you send me over email, because I don't know if you guys can understand this, but it's insane trying to keep track of that. I can't use the Canvas speed grader thing. That's really nice that I can mark it up easily. And then I have to, anyway, you don't have to know much, just don't do it. Any other questions about logistical stuff or from homework stuff or anything? No. Okay, I want to show you something real quick. Let me see if it can be real quick. There we go. So take a look. If you go into Canvas now, you will see this final exam preparation thing that's brand new. So there's that review sheet I promised I would put up here. So it looks like this. It kind of just reviews all the main topics from all the chapters. Oh shit, I was supposed to, this is obviously from last semester. I did put this up here. I gave this out, I think, to you guys. The Greek alphabet, yes. Just pay no attention to this. That's obviously from last semester. Okay, what's going on here? Chat. Can't, oh, really? What do you see right now? Oh, I didn't switch over. Okay. Dadgummit. I don't know how to make this thing work easier, but oh well. Where are you? There it is. Here's the sheet. Thanks for letting me know. Don't just sit there and say, well, I guess it's just me. Say something. There's the review sheet, right? On the back is this. Just pay no attention to this. It's from last semester. Yeah, so this always helped me to review when I was a student. I would try to go through each chapter, make sure I understood the basic, the most important ideas from that chapter, right? So maybe you can use this as a checklist, or maybe you don't use this at all. That's fine. Everybody studies differently. I won't take it personal. Let me see. And then, let me close that up. Arg, why are you doing that to me? Here we go. And then, of course, there's also in that same place a practice final exam. Look at that bad boy. Look how long it is. That's so awesome. All right, you probably don't agree. Oh, all kinds of good shit on there. So, oh man, I will commit to this, that I will make a video of the solutions to this. Why not? I'll see if I have to be able to do that. I need to put this somewhere where I won't forget. My notebook is completely full. Practice final 160 review, 160 solutions video. Bam. Okay, let's see if that actually happens. That'd be so cool if it did. Okay, so you got those. Both of those you can just ignore completely if you want to, right? It's just me trying to help you study for the final. If you have other ways to study for the final that are better for you, then do those. I don't know what's going to work for you. Any questions over that stuff? Also, if you go into Canvas, I just updated the overall averages. Now it says, oh shit, I forgot to change this. It now says as of May 17th. Bam. Yay. Right, so you can go in there and take a look. If you've submitted quiz corrections or anything over email, that more than likely is not represented in there yet. So you will give me time because you have no choice but to give me time. In the future, please upload those directly into Canvas. It makes it easier to keep track and all that kind of stuff. Come here. Okay. Any questions on anything we just went over? Okay. All right. I want to do this. If there's no questions from homework, which is a little troubling, but I'll get over it. I want to show you this. It's kind of like a little review of the last couple of chapters, a very, very surface level review. Can you guys see this 12, 11 skills? Yeah, with the scatter plots? Okay. Take a minute. Everybody take a minute out there. Get a piece of paper, which hopefully everybody has out and ready already anyway, because we're in class. All right, I'm in an interesting mood this morning. Do number 1, sketch a scatter plot of data for which r equals -1. Let me say this. Use at least 3 data points. So I don't blame you if you use just 3. I don't blame you. It's fine. Okay. All right, guys. Anybody willing to? All I want you to do is number 1, right? Sketch a scatter plot of data for which r equals -1. Anybody willing to share? Put it up on your screen. Ooh, somebody's doing it. Wait, let me, hold on. Just keep it right there. All right, put it back. All right, guys, what do you guys think? Can you all see that? Whoa, hello, now we can see it. Anybody disagree? Anybody think that's no good? Okay, that's good, Olivia, thank you. So why, hopefully more people had something like that. Why was that correct? What does it mean for r to be -1? 2 things. The negative part tells you that the line must have what? Negative slope. There it is. Down slope. I love it. And the 1, so negative means negative slope. And what's the 1 mean in r equal -1? 1 means what? I know what you mean, Monica, but be more specific. All the data points. Okay, perfect correlation, but what does that mean? Perfect negative slope. Great. What's it mean? I love you guys so much. Monica got the closest so far. All the data points have to.
Is it all aligned with the best line of it? I don't know how to say it.
Here's how you say it. You ready? All the points, all the data points are on the line.
Okay.
Bam. That's all. That's it. Not close. Close would mean -0.99 maybe. Perfect means they are all on the line. So sort of like, remember how I said R is kind of like a 2-dimensional standard deviation. I have no idea if you guys like or hate that, but it's such a beautiful idea because the line is like the average and the R is sort of acts like a standard deviation. It doesn't really have the same values because standard deviations can't go negative, but we know that a negative means that it's a, how do I do this for you guys? Negative slope, does that look right? I can't tell. Negative, who knows? It's got a negative slope. What was I had a point. Shoot. Oh, well, too bad. So yeah, so if it's perfect correlation, then all the points have to lie directly on the line. Which means, there's my point. If I had a set of data and every data point was the same, doesn't every data point equal the mean? Don't all the data points lie right on top of the mean, right? And that would be an extreme standard deviation. In that case, the standard deviation is 0. So the line of best fit is the average of all the data points. And if R is 1 or -1, that means that all the data points agree with that average. They're all the same. There's a beautiful analogy there. The numbers aren't the same, but the ideas are the same. Okay, maybe. So let's do the second one. All right. Bam. All right, look at these two pictures here. This first one, don't chat, don't say it, just write it down. Is it weak, negative, strong, positive, strong, negative? What is it? Is it weak or strong? And is it positive or negative? Just write it down. No, don't say anything. Sorry, Siri Claire. And then for part B, the same thing. I don't know if you can see that well enough. Let me see. Whoa. All right, now, so Sirikarn's got 2A. It's weak, and it is positive. I love it. Just barely. In fact, I would guess that this isn't even evidence of correlation. The R is probably not big enough, but if anything, it would be very weak positive. Crazy weak positive. In fact, let me tell you guys something. Look here real quick. Watch. See these 3 data points right here? See those 3? If those were taken away somehow, like I never got them in my sample, wouldn't it be strong negative correlation? Do you guys see that? See the remaining data points would be these? Wouldn't that be maybe not strong, but a lot stronger than this? That's kind of weird, isn't it? So when I see that type of thing happening in a correlation study, I'm very curious about what these are. Either there's something weird about these 3, or if I did a lot more sample, a much bigger sample, maybe there would be more points to really show me that this is right. But if I did a much bigger sample and I got stuff, yes, exactly. So if these 3 were anomalies, were mistakes, were incorrectly written down, you guys with me? Then what would happen if I took a larger sample? Wouldn't there be more data points like here, here, maybe? Do you guys understand what I'm saying? Maybe? No? That's why for a very small sample, R has to be so big to be evidence that there is correlation, right? Because these 3 could be mistakes. Or I take a bigger sample and I get a bunch of data points like here, just to really reinforce that trend does look correct. So the bottom line is I need a bigger sample to see what kind of correlation this is. So again, I'll bet you anything 2A doesn't have a big enough R to show correlation at all. Remember that R greater than something or R less than something to be evidence of correlation, which would say I need a bigger sample to try to find evidence. Because right now I don't know what trend is correct. Maybe those 3 are outliers, right? Who knows? Okay, that's enough of that one. And then look at part B. Part B is much nicer, right? Part B is much more obvious. What's this one? Strong negative, that's right, because all them data points are so close. Well, what's a good guess for what R is on that one? Somebody give me just a guess for what R would be. No? Pay attention to what you just said. Just change one thing there and it's beautiful. Yeah, so maybe negative 0.98, Sirikarn, negative 0.9. Yeah. Those sound reasonable, right? It should be close to -1 because it's strong and it's negative. Okay, good. I love it. So the problem with a lot of mathematics is students get so wrapped up in the details of what they're doing that they forget the basic idea behind what it is they're doing. That happens so often in mathematics. And you're all like, yeah, dude, I live it every day. So the next thing I want you to do, I want to do this with you guys, sort of. I want to kind of show you, we haven't done a problem like this. What kind of problem is this, number 3? What's kind of the name of this kind of problem? Anybody know? Oh my goodness, right? Goodness of fit. Does that sound familiar? No? That weekend wiped everything out? Man, what do you guys drink? Okay. Take a minute and put the O stuff. What does that stand for, O?
Observed.
Observed. And E, of course, stands for?
Expected.
Expected. I love it. Can you tell me what kind of distribution we expected it to be? We can tell right there. What kind of distribution did we expect it to be? You could do it. You could do it. No?
Uniform.
No. Uniform. All the expectations are equal. That would be, we expected it to be a uniform distribution. Where to get 11 from? Well, if you add up all the observations, they make 121. And there are 11 categories. 121 divided by 11 means they each get 11 for expected. Now, just on the surface, do you guys see, does this look really far off from this? Look at the whole list. Does the observations look very far off or decently far off from the expectation? There are a couple that definitely get kind of far away. You guys see that? Like there's that 3 that gets pretty far away. 16s maybe are a little far away, right? So it sounds like maybe it's a little bit far away, but I can't tell. So let's do this. In your calculators or whatever the hell device you are using as a calculator, put the O stuff into L1 and the E stuff into L2. There it is. All right. I'll do it with you. This is so exciting. Data entry. If you need to take a break and walk outside from the sheer excitement of data entry, I will understand. I can't take it. It's so amazing. At least the second column is really easy to tell if you made a mistake. If it ain't 11, you made a mistake. All right, so already got that. So it looks like this. Oh, shoot. Let me turn my trees off. Sorry, trees. It's all right, man. This is good, Jeff. You're speaking to your images. This is always a good sign. Okay. All right, so there's the data in L1 and L2. What do I want to make L3 be? What do I want to make L3?
L1 minus L2 squared.
Kick ass, right? L1 minus L2 squared. So I'm going to go up to L3, and then put in there, parenthesis, L1 minus L2 squared. Remember, your L1 and L2 stuff is above 1 and 2, right? L1 minus L2 squared. Make L3, L1 minus L2 squared. Enter. Okay, right? Everybody with me? Anybody not with me? Let me ask it like that. Do you have to do the list stuff? No, you don't have to. I just want to do a problem and show you that it works the same way as it did before. What do I want to make L4 now?
L3 divided by L2.
Shot, dude. So we make it, where'd it go? L3 divided by L2. Right? It would be the observed minus squared divided by E. So if I make L4, L3 divided by L2, I'll get that business. Okay. And then I could hit, and then I could hit. Now, what do I want to do there? I want to, of course, add those up. So to do that on the calculator, I could do the old thing we used to do. Remember, hit second quick, get out of there, hit stat. So get back to the screen. Hit stat. Sorry, second stat. Then I want to do some math. I want to do the sum of L4. Do you guys remember that? If I sum up L4, I get that. Now, I don't know if you guys, this is a very difficult question for anybody to answer. I mean, does that look like it's big? We don't know chi-squares well enough, and it depends on the degrees of freedom. So let me say chi-square. It's okay, Jeff. It's all right. There you go, buddy. All right, let me stop right there. Let me just stop right there. That is more than half of a goodness of fit test problem, right? And that's all I ask you to do on this. But if I wanted to go one step further, can we look up what the chi-square would be for the rejection region? Is that 15.455 actually related to a large difference, large enough to be evidence that the population is different? What are my degrees of freedom? Where's my chart? That's a good question. There it is. Hey, I found it. What's the degrees of freedom? Degrees of freedom. How many degrees? No. Ugh, no. How many categories are there? Oh, no, not 13. How many categories? Yeah, there's 11 categories. So degrees of freedom would be K minus 1. So degrees of freedom would be, I like it. And I don't tell you alpha, do I? Because I didn't mean for this to be that kind of problem, and I don't care. What do we assume alpha to be when we don't know? What's the basic alpha? You're so basic alpha. What's the assumed alpha if I'm not given one? Anybody remember? It's been this way for a long time. When I don't know alpha, what is the standard value to use? This showed up in several homework problems. Okay, nobody's telling me anything. My internet connection's unstable. Don't you say that. I checked it this morning. All right. Everything looking okay on my side, or am I out? Am I gone? Are you guys still there? Can somebody tell me, does it look okay on my side? You guys are freezing up a little bit for me, so it looks good?
Yeah.
Okay.
Oh, wait.
I just got the evil, you guys have seen this
fine,
message,
but
right? Where it says, I'm kind of spotty with moving. Okay. All right. Well, that kind of sucks. Oh, man. Oh, I got you. Thanks, Kate. So it's right there on the screen, right? You guys see it? Now you know the answer to my question, right? Did you remember that? 0.05 is the standard value to use. If you don't know. Okay. So can you look that up real quick? What would the chi-square be from the chart? The chart. What would it be from the chart, matey? Degrees of freedom is 10. Alpha is 0.05. What's the chi-square for the rejection region? Yeah, 18.307. I'm not sure we're getting 3.169. Where would that come from? I don't know. Where is that coming from? Yeah. Okay. So, I mean, degrees of freedom are 10, right? Then you go over to where it says 0.05. Degrees of freedom of 10. I don't know. I've lost it now. But degrees of freedom 10, 0.05, and I see 18.307. Good. So would we have made it far enough away? Was that a big enough difference? Was that difference we got, this chi-square, basically represents the squared differences. Is that big enough to be evidence that it doesn't follow the expectation? Do we make it into the rejection region if the rejection region starts at 18.307? Did we make it in with our 15.455? No. So we did not find evidence. We did not find enough evidence to say that it did not meet expectations. And this is where people still make the same mistake. They're like, well, I can see it right there, Jeff. They're different. In fact, only one of them's 11. So you're full of shit, Jeff. And not many people have said that to me, but I'm almost certain they've thought that about me. But this is a sample. This came from a sample. Samples will almost definitely vary from the expected value. And that doesn't mean that something's wrong. If I roll a die 100 times, let me say flip a coin 100 times, and I don't get exactly 50 heads, I don't freak out because it was a sample. It wasn't every flip the coin could do. Right? And that's why we have this this benchmark that we have to get past to be evidence, because it's just a sample. Okay, maybe. We does that sound very familiar by now? Hypothesis testing, we thought about that kind of idea. Okay, maybe not. Okay. So hopefully that helped out. Again, if it's a small set of data, you don't have to use you never have to, but if it's a larger group of data, more categories, you might want to use the lists to do this real quick, right? Monica, know what? Are you okay? No. Okay.
You had asked if we made it into the rejection region, and I said no.
Oh, I'm sorry. That's from before.
Yeah, it was
okay,
to your last.
I got you. They should have a little time stamp on those. All right, here we go. All right, enough of that one. Bam. So the final exam will obviously have a chi-square problem. We're not going to have a quiz on chi-square stuff just because it's just not enough time, right? At this point, if I'm you, I need as much time as I can to catch up on homework and to maybe try the practice final out, all that kind of stuff, right? Because you guys remember when the final is, do you? Are you guys the one that I had to double check? I don't think so. I think I knew you guys for sure. I see people writing stuff. Hold on. It's on the no quiz. No, this Wednesday is the last day of class. So it'd be so mean of me to give a quiz this Wednesday. It's not 7 a.m. though. Is it 7:15? Where are you? There we go. Monday, Wednesday. Dadgummit. Whatever, Jeff. I'm going to find it later. I can't find the homework stuff for you guys for some reason. It's on the homework sheet. All right. I'll double check before Wednesday and let you know. It's on the homework sheet when our final is. It sounds about right. I think it starts at 7:15, if anything. Okay, let me see. So that's next Wednesday. That's a week from this Wednesday. Next Monday is a holiday, if I remember correctly. So our final is a week from this Wednesday. Okay, so what I want to do now is maybe start the review a little early. We basically have finished everything. We have finished initially discussing everything. We're done. We're done for the semester. No new stuff to happen. I want to see if you guys, let's see. Let me share this practice final again with you. Where did I put you? Did I close you? I probably did. Oh, I definitely did. There it is. So let me share this with you. Maybe I'll share two things. Look at this first. Right, this is going way back, but let's start closer up. So obviously we just did chi-square, right? Where you have to know how to do a goodness of fit. You have to know how to read the chart. Do you see how to read this review sheet? Let me see, where am I at? Here we go. Then you go look back at chapter 12, line of best fit, R, scatter plot and line. Now be really careful in the homework in chapter 12. Some of you guys are using the calculator too early to graph scatter plots. In the first couple of chapters, they just say make a scatter plot. They don't say use the calculator to find a line of best fit and all. I want you to do it by hand. Yeah. It's a little review about how to plot points. And then 12.5 is where you really use the calculator to figure out R and the line of best fit and all that kind of stuff. Then you go back a step. So this is a line of best fit, R, and how to interpret R, and the scatter plot and the line on the calculator, right? And then you go back. Then we have hypothesis testing. Remember good old hypothesis testing? When to use Z and T. The 5 steps. Now, I wrote this down. I want you to understand what they are. Now, listen. If I have more than one hypothesis test on the final, the first one will have the 5 steps, A, B, C, D, E. And then the second one might just say, test the claim using all 5 steps. And you just have to go back and see what A, B, C, D, E are. So I'm not going to make you memorize what the steps are. You got to make sure you understand what the steps are. Does that make sense? Or does that not make sense? Sorry, let me say it like that. And then, of course, the only truly new thing in chapter 9 was the Z-star formula for the p-hats. Remember that? That was the only truly new thing. Anyway, so I'm not going to go through this whole chart with you, but that's how I would do it, is I would kind of go backwards, because I can firm up the stuff that's more recent in my brain, because as I go backwards, I'm probably going to need a little more review as I move up this thing, right? I'd rather reinforce what I know recently and then work on more review of earlier stuff. So let's look at the practice final real quick. All right, so one of the most important kind of problems we did this semester, and I don't know, maybe you guys, I kind of want to ask if you agree with something I said earlier this semester. Let me see. What do you guys think? Don't tell me what I think. Tell me what you think. What do you think was the most important chapter this semester? The one that had the most to do with more of what we did. Oh, interesting. In a sense, I agree with you, Monica. So that's I didn't really think of it, but yeah, probability is huge because we do p-values and their probabilities of things, and yeah, that I can agree with. So let me ask it, let me say, what's the second most important? I'm hoping you came into the course with some idea of probability, right? So this, the top 2 would be probability and chapter 6. Yes, normal distribution with z-scores. Z-scores ruled our lives. And sure, we came up with t-scores, but aren't they based off of z-scores? Do you see them? So z-score, that I said at the beginning, that was going to be our most important chapter, was chapter 6. So the very first problem on this practice final is a chapter 6, chapter 7, because remember chapter 7, I think, yeah, chapter 7 introduced central limit theorem, which is kind of like the first tweak on a normal z-score problem. I don't know if you guys are with me or not. Okay, so number 1, you want to find that problem and do it. Because sometimes people just go through the final as it comes, and when you hit this problem, you're just not in the right mindset, and you don't know what to do with it. And it should be the easiest problem, because we did so much of this stuff, right? Take the x value, change it into a z-score, look it up on the chart. For part A, you're going to have to do 1 minus what you get. So a lot of people didn't draw the picture for themselves. They had a problem like 1A. They got the z-score, looked it up, and gave you that. And that was wrong, because you had to do 1 minus that to actually answer the question, right? So if you draw the picture, it's supposed to keep you anchored as to what the actual answer should be, what makes sense for it. All right. What does this mean again? This weird thing here, is that a new fitness craze? P95X. 5 better than P90. What's P95? What does that mean? Anybody? Yes, the 95th percentile. I love it. Remember those? Oh yeah, they're gonna come back. And then of course, what do I do in number 2? This should really be second nature for us. If you don't remember them, go back and study them because they're gonna come up again. What do I have to do on number 2? What's the very first thing I should do on the second problem? So look up here. This gives me a mean and a standard deviation, right? What kind of standard deviation is this? Yes, good, Monica, that's right. That's the answer to my other question. You got to change the standard deviation for these problems because I took a sample and I'm asking about the sample mean. I've got to do sigma divided by square root of n. Do you see, did I take a sample up here in number 1? Did I take a sample? What group are they talking about? Are they talking about a sample? They are talking about for US adults, the population. So this is population data, right? Which is why it's okay to use the z-score chart because it's population standard deviation. All right. Let me see. I'm not really sure. I came in today thinking there would be more questions. So I've gone past where I thought I'd get, but this is good. I wanted to start the review a little bit, but now I don't really have a plan for what the best way forward on doing this review. Would you rather maybe right now try this problem out? This is the most recent stuff, the goodness of fit problem. Do you guys want to try this problem out? Anybody? Will we have to write down the questions? No, I made them. I will know what they are. You just have to do the work and then scan that and send it to me. You can write the question down if you want to. And everybody understands that what I'm going to do is on the day of the final, in fact, I got to do 2 things. I have to make an office hour schedule because our final is on Wednesday, but Tuesday I'm going to have like office hours, right? So there will be times that I will be available on Zoom. If anyone has a preferred time, you could let me know, but I'm not going to be able to accommodate everybody, unfortunately. But I do want to have some times. Okay, and then I forgot the second thing now already. On the day of the final, I will be in Zoom early. And then the minute, I think it's 7:15, the minute we hit 7:15, I will make the final exam active on Canvas. You go get it and you start working on it, just like a quiz. The difference is I'll be staring at you because you all will have your video cameras on. And I've asked several times to tell me if you have any issues with that. That's the only way I can keep this, the integrity of it. Not everybody is cheating, which is really, really appreciated. But more are cheating than before, which is really sad. So I need to keep some integrity, especially on the final exam. Yes. I'm considering, on Wednesday we'll talk about formula sheet, what you can have on your formula sheet. What I might do, I might create it. I hate doing that. Well, I don't know. I might make one for you, but you get something out of putting it together yourself. What was in the middle of saying? I can't remember. Any other questions about that? The final, how it's going to work? Okay, no? Okay. So, would anyone like to focus on this problem and try it out? For the expected, do we convert the percent to whole number? No. No. You try not to round it too much at all. In fact, specifically on this problem, I would recommend using the list. So let me show you. Let's do this one a little bit together here. I've got to blow my nose. Can you guys take a second and fill in the observed while I go blow my nose. I'm going a little. I look about the way I feel. Let's see. There we go. All right, what do we got? What did you guys put here? This first one. No way. 51, and then it's easy. Just I have to tell you what the observed is because you're not actually making the observations. You have to go up based on what I saw. Now, what's really cool, now watch. Well, I'm not gonna, well, screw it. Anyways, I'm not gonna worry about that. So what am I gonna put in for the expected here? Well, how many A's did I expect? Well, there are 342 students. And what percentage of A's do I expect? 13%, right? So I would do 0.13 times 342, and it's going to come out a little gross. Not too gross. 44.46. So really, one of the most important things is do not round too early. So to be really honest, it'd be cool to use the lists, because with the lists, watch what you can do. Watch what you can do. Let me see. Hold on. Let me get it. Watch what you can do. Yes, Jeff. Watch what you can do. We got it, Jeff. All right. Now in the list. So I got the observed in there, right? Now watch. In list 2, I can do this. 342 times 0.13. I can just put 342 times 0.13, enter. Yay! And then keep going. 342 times what? For B's. What percentage do I expect for B's? %. So then, oh shit. So if you do 342 times 20%, you get that, right? And then you know, keep going. So let's see, we get 68.4. I don't think any of these you have to round too much, right? 342 times shit. Not shit, Jeff. No C shit. 342 times 0.34. I get 116.28. Yeah, these are not too bad. Right, and then it's symmetric. Do you guys see that? So it's going to be 68.4, and then it's going to be 44.46. I don't have to do that work because I already did. What do you guys think this is? What do you guys think this kind of roughly represents? Anybody have any idea what kind of distribution this roughly represents? Yes, it roughly represents a normal distribution for 5 categories. Very roughly. So this is sort of a test to see if the grades do follow a normal curve, or do I find evidence that they don't, right? All right, go ahead and finish this chart out if you want to. If you don't want to, then, you know, just continue sleeping or whatever it is you're doing. Oh shit, and a half. Ooh. I'm going to put what I got here. Oops. Holy shit and a half, Jeff. You guys cool with these numbers? Let me see here. See, they're rounded up here, but they're not rounded in my, so I want to show you, for example, if I do this in the calculator, do you see how it shows 216.68 there? But you see how down here it's not actually rounded? So when you use the lists, it's kind of nice because you can put up on the paper a rounded version of the number. In the calculator, it didn't round it. So when you do calculations, it's not going to make those kind of errors where things are rounded too much. So some of you guys round everything too early, and then that could throw the answer off way more than you think. So anybody not with me on those numbers that I just got? Because you never know. I could go temporarily insane, or, oh, we're almost to the degrees of freedom. No. How many categories are there? Yeah, there's 5 categories. The degrees of freedom is 1 less. So if you want to get ahead, go ahead and try to figure out what the chi-square for the rejection region would be. These are the rest of the numbers I'm getting from this. All right, so I just didn't round over there just because. Our numbers are matching. Yay! Livia and me both got the wrong stuff together. No, maybe we're right. We could be right. So the rejection chi, which is not like the supreme chi, the rejection chi would be based on the degrees of freedom, right? And the alpha level, degrees of freedom are 4, and the alpha is 0.05. Right, because I tell it to you, and if I didn't tell it to you, you would assume it was 0.05 anyway. But I tell it to you right there. Bam! 0.05, buddy. So what's the critical chi-square? What's the rejection chi-square going to be? Yes, 9.488. Make sure you can find that on the chart. And what's the calculated chi? What's the summation of those? What's the chi-square we get from summing those up? So you get 5.535? Sounds about right. I didn't actually do it. I don't know. I'm going to take your word for it. Hey, there we go. Okay. Apparently I didn't take your word for it. So did we find evidence that this class of these students did not follow a normal curve? Did we find evidence they did not follow the expected distribution? No, because we had to get this far away and we only got this far away. So was that sample I took different from what I expected? Yes. Was it evidence that the population of students does not follow a normal curve? No, it's just a sample. They didn't make it far enough away. So we have not found evidence that all students don't follow this distribution. You gotta love the double negative, but actually it's always a double negative. Reject is a negative, and reject, and anyway. We have not found sufficient evidence to say that the students don't follow this distribution. Maybe that's a better way to say it. Oh, because on a goodness of fit test, and again, I didn't make these like all the steps for hypothesis tests, right? You're welcome. But if we did think about it like that, the null for a goodness of fit test would always be that the observed equals the expected. That would be the null. Let me let that sink in. We expect it to be those. So our null hypothesis is the observed will equal that, right? Or the population would equal that. And then our sample, we're trying to show evidence that it doesn't equal that. Now that sounds like, now I don't want to get too deep into that because that sounds like it should be a two-tailed test, right? But it isn't, because remember we folded the thing over, so it made it a one-tailed test. All I had to do was be far enough away. Anyway, I don't want to go too deep down that rabbit hole, right? We could get a lot further into the details. It wouldn't change the result of our test, and it actually wouldn't really illuminate too much for us, which is why I'm okay with not making it a full hypothesis test. And I'm certain you feel the same way, right? Is anyone disappointed that I didn't make these into a full hypothesis test? No, okay, that's what I expect. All right, if you are disappointed, truly, you have a special place in my heart. Okay. Blah, 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 blah. Look at these. Oh yeah, this one here. Look at number 9. I need to put a little note, somewhere for yourselves. This would be extra credit. I don't know if you guys see why. Whenever we do a hypothesis test, how many samples do we take? When we did our regular chapter 9 hypothesis test, how many samples did we take? No, not 2. No. So when we did a regular, like this one is a regular hypothesis test right there. You feel that the percentage has increased for the people that got to take more than 2 finals. The percentage for the last several years is this. You take a survey of blah, blah, blah. So that's 1 sample. So in chapter 9, it's all about 1 sample. Z star is p hat minus p. 1 p hat, not 2. There weren't 2 samples. X bar minus mu over, okay, 1 X bar, not 2. So I know maybe 1 person so far has turned in section 10.2 homework, which is extra credit. You don't have to do it, but chapter 10 is take 2 samples. If you have done chapter 10 homework, the formula is much bigger because it has to have 2 X bars, X bar 1 minus X bar 2. And it's got to have 2 S's or 2 sigmas because you have 2 samples. Anyway, sorry. So that's why this one is extra credit, because it comes from chapter 10, which is all about testing 2 samples. You guys with me? I forgot that I put that on there. This is a regular hypothesis test here, right? Because we have a claim, we have 1 sample that we took, a regular everyday hypothesis test, right? And of course, we all know this one. This used to be me right here. My God, that was a data point in this. That was me. Thankfully, I've lost a little weight since then. I moved further away from Bronx Pizza, by the way. I don't know if any of you have ever had Bronx Pizza. It's been a while since I had it, to be honest. But man, back in the day, they put some crack in the crust. I don't know what they did, but that stuff was too much. Anyway, you don't have any strong opinions about pizza. Okay. All right. Let me see what else we got here. Now we're going way back in time. Can anyone tell me what kind of problem number 4 is? What's the 35? What letter would represent 35? What letter would represent 35? And what about 9%? 9% think that getting all children assured is not a priority. These are spectacular people. No, not X. 9% believe that's a probability. That's P. So what would Q be? Yeah, 91%. Yes. So what kind of problem is this? You could say NPQ. I used to call it, right? I think I've called it an NPQ problem. What's the technical term? Starts with a B. That gives it away right there. Starts with a B. Binomial. All right, I like it. Right, so this is going to be n choose x, p to the x, q to the n minus x. Maybe you remember that. And then we got NP and square root of NPQ for standard deviation. Remember? And the min and max go up and down too. Oh, shit. All right. Don't remember that, Jeff. Damn. And then, of course, you got this one. This is really going back. Remember these guys? Sum of x p of x. You got to make x p of x and x squared p of x and all that kind of goodness. Yummy, yummy. Yummy, yummy, yummy. And then we got straight up probability problem. And then we got the problem we started with. Okay. All right. So I've talked about every problem on that practice final. Do you have to do the practice final? No, you don't. If I were you, I would at least look at it, make sure I could tell what kind of problem it is. The main thing to focus on, of course, is homework. But I will be posting the solutions video for this. Hopefully in the next 2 days. No, let me take that back. Hopefully this week sometime. Yes, I feel better with that. I'm thinking tomorrow afternoon I'll be able to do this because the meeting I always have on Tuesday afternoons, we had our last one last week, so I'll actually have time. All right, guys, we're running right up against the time to stop. So any specific questions or anything? So this Wednesday, I'm going to go through a more detailed review. I'd love it. I'd so love it, and so would you, if you came with specific questions about anything from the entire semester, because the final is all about that. And if very few people log in at, oh, Monday is a holiday, but I think I could have, so by Wednesday, I'm going to have a schedule of my hours for next week, because Wednesday is our last normal, normal as it is, lecture time. You guys with me? This is the last week of classes right here. It's the last week. Next week is finals. So I've got other finals to give. So I'm going to schedule some office hours around those other finals. You with me? So I could do Monday. Monday is officially a holiday, right? Am I remembering correctly? All of a sudden, I feel like I went a little insane. I think Monday's a holiday. So I could have office hours on Monday. That's fine, because we're not able to do the normal holiday stuff. And then Tuesday, sure. Tuesday. So again, next week it's all different, because my finals in my other classes are, kind of all over the place a little bit. So I will have a schedule on Wednesday of when I will be available on the Zooms, right? And I'll send out a link for next week's Zoom office hours meetings. And I'll have one link for, will I? I don't know if I could do that. Have one link for all of them. I don't know. I'll do as best as I can. You'll have links for all the office hours that I'm offering next week. Of course, our finals on Wednesday. So Monday and Tuesday is when you want some office hours. But come as prepared as you can this Wednesday with questions. If nobody has questions this Wednesday, we'll just do some problems off the practice final together. I mean, but come with questions and feel completely fine asking them, right? So anything else right now? Anybody? Anything else? At this point, if there's anything you've missed, quizzes and stuff, I'm going to do what I would have done before with like a late missed test or something, is count the final exam in place of the missed stuff. So somebody just asked me a private question about making up some quizzes they missed because of emergencies that happened. I'm going to count the final exam in place of those missed quizzes. Much better than getting a 0 on them. Anything else, guys? Any other questions? Okay, and as always, I have met with students on Zoom one-on-one. I would rather, have a little group, but you could always do that. If you want to talk about, I'm going to try to get our grade for final. What do you? Oh, when the final is taken, when we take the final, you can immediately email me and say, "Can you let me know how things came out?" And then I'll just email you as soon as I'm done. I'll email you back. So I love how students are like, "I don't want to email you too early because then you're not done." Email just sits there until I get to them. So you can email me before the final and say, "Hey, just reply to this email when you find out what my grade is." And then I'll go back through and I'll reply to the emails I get. You guys with me? Try to go ahead and wait until after the final's done. Makes it easier for me to find those emails, right? Is everybody with me? I mean, I will be putting them into Web Advisor. You will be able to see them in there, but sometimes it takes them a while to update grades in Web Advisor. So I understand that. Any other questions, guys? Anything else? No? Okay, that's plenty. We went a few minutes over. All right. Thanks, guys. So I'll see you on Wednesday, right? Just come on in on Wednesday. I'm there a little early all the time, 7:30. And come ready with questions, please. Monica, you okay?
Yeah.
Oh, I'm sorry. I just saw you unmuted yourself. I thought you were going to say something.
Oh, no.
Okay. All right, guys.
Thank you.
Bye.